So here's a model of a cantilever bridge. And a cantilever is what, again?
Cantilever is something where it's only supported on one side, as you can see here, and hanging off the other.
Okay. So with this cantilever bridge, let's bring up that poster. So again, it sort of works like a seesaw.
Yep.
There's the pivot where the triangle is.
And that translates to
which would be
right there.
Right there, okay. So to make sure it doesn't tip over, the torque has to be equal on both sides.
Yep.
And on the left side we have the tower. And so everything to the left of that pivot point is 6 pounds. And torque is measured.
Weight times distance.
So that's the weight.
And our distance is taken from the center of gravity, our line of force, its shortest distance to the pivot point, which is a right angle, and that's 12 inches. So we take our weight times distance, 6 pounds times 12 inches, and we get 72 inch-pounds of torque just on the left side.
Good, and the right side?
We do the same thing. We take weight times distance, so our weight of the deck is 2.75 pounds. Center of gravity, shortest distance to the pivot point, that's 20 inches. Multiply them together, we get 55 inch-pounds of torque, but we still have to include the weight of the little piece of wood at the very end, which is only a half a pound, but because it's so far away, 40 inches away, that comes out to be 20 inch-pounds of torque. Add these together, you get 75 inch-pounds of torque, 72 inch-pounds of torque. Our numbers are crude, that's why it's not falling over right now, but it's very close in balance.
Okay, now if you take that poster down, if you put a tiny bit of weight at the other end, it doesn't take much to tip everything over.
Not at all. In fact, if you take off this piece of wood, it'll fall over.
And that's only half a pound.
And it's fairly close too.
But that makes all the difference. Okay.